Okay, so let's continue talking more about the periodic table. So the elements in the periodic table are arranged by the atomic number. So the atomic number is the number of electrons that that particular element has. In a neutral element, the atomic number is also equal to the number of protons. So each column is called a group. So the group number is the number of electrons in a valence shell. When you think about the shell, think about positions or locations. So a typical example that I use in my class, or a simple example, is that imagine that you have a car. So a car has the front part and the back part of a car. So the shell will be either the front or the back of the car. So on the first shell, just like the front of a car, you can have a maximum of 2 persons. In the case of the element, you can have a maximum of 2 electrons in the first shell. And in the second shell, it's kind of like the back in the car, you can have a maximum of 8 electrons. Each row is called a period. So the period is the number of shells or orbitals that that element has. So the valence shell is the outermost shell in an element. Now, the electrons that are found in the valence shells are the ones that are involved in bonding. The valence shell contains up to a maximum of 8 electrons, but for most of the time, it's not actually full. Now, the number of electrons are important in determining the types of bonds that that particular element is going to make. So when you look at the periodic table, you're going to see that each element has different things. So let's talk about what each of those things are. So each element is going to have an atomic number. So an atomic number is equal to the number of protons, and in a neutral element, that number is also going to equal to the number of electrons. Each element is going to have an atomic symbol. In this case, we're talking about Ne. Each element is going to have the atomic name. So in this particular case, we're talking about neon. And each element is going to have an atomic mass. So the atomic mass is equal to the number of protons plus the number of neutrons. And as we already talked about, the protons and the neutrons are located in the nucleus of the atom. Okay, so if you want to know how many electrons can you fit in each of those shells, just count how many elements are found in each shell. So for example, in the first shell, you have hydrogen and you have helium. So that means that you can have a maximum of 2 electrons. On the second shell, you have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. So you have 8 elements, so that means you can fit a maximum of 8 electrons. On the third shell, you have sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. So you have 8 elements, so that means on the third shell, you can have a maximum of 8 electrons. Okay, so on the last column, so where you have helium, neon, argon, this is what we call the noble gases. So the noble gases are non-reactive. And the reason why they're non-reactive is because their shell is completely full. So they're basically happy. And every single element wants to be in the last column. And so let's say, for example, in order to do this, certain elements are going to gain electrons and other elements are going to lose electrons. So fluorine, chlorine, those elements are so close to where the noble gases are. And so that means that these elements are hungry for electrons. So that means that these elements are going to steal electrons from other elements in order to be there. And the elements that are farther away from the last column, such as for example lithium, sodium, because they have an extra electron in the valence shell, what's going to happen is that they're going to tend to lose much easily that electron in order to be where the noble gases are. Okay, so there are three types of bonds that we can make, and they vary by strength. So the first type of bond that we can make is a covalent bond, and this is the strongest type of bond that we can make. And the reason why it's the strongest is because two elements basically share an electron equally, and so both elements are happy. So rather than fighting for that electron, what they do is they just basically share it equally, and this is why this bond is the strongest of the three types of bonds. So the second type of bond that we can make is the ionic bond. So the ionic bond is a strong bond, but it's not as strong as the covalent bond. So typically, the elements that are gonna be making ionic bond is gonna be the elements that are found on the right side of the periodic table and the left side of the periodic table. And if you remember, I told you that the elements on the right side of the periodic table, the ones that are closest to the last column, they tend to gain electrons. And the elements that are on the left side of the periodic table, they tend to lose those electrons. So an ionic bond typically is going to be made between elements that are on the right side of the periodic table and elements that are on the left side of the periodic table, or elements that have opposite charges. And the last type of bond that we can make is hydrogen bond. Now, a hydrogen bond is the weakest of the three types of bond, but it's extremely crucial for the survival of us, for the survival organisms, that this type of bond is the weakest. And we'll talk more about that when we talk about DNA replication. So the reason why it's the weakest is because it is a partial attraction between two molecules. So for example, here we have two water molecules. So water molecules made out of one oxygen and two hydrogens. So oxygen is one of the most electronegative elements that we have in the periodic table. It's not the most electronegative, but it's one of the most electronegative elements. So that means that they're hungry for electrons. And so what's going to happen is that they're going to try to steal electrons from other elements. Now, hydrogens also want those electrons, but it's not as strong as oxygen. And so what happens is that the electron that is found in the hydrogen molecule spends the majority of the time near the oxygen. And so because the electron has a negative charge, what's going to happen is that it makes the oxygen molecule partially negative. And because that electron carries with it its charge, then that makes the hydrogen partially positive. So whenever you have two water molecules, they're basically interacting with each other. So the partial positive of the hydrogen is attracted by the partial negative of the oxygen in the opposite oxygen molecule. Again, it's a partial attraction, so that's why this is the weakest of the three types of bond. But if you have a bunch of hydrogens, a bunch of hydrogen bonds, then it becomes strong. Now, one important thing is that in order to have a hydrogen bond, you must have hydrogens, and you must have at least one of these three elements. So in addition to hydrogen, you must have either fluorine, either oxygen, or nitrogen. So only these three elements can do hydrogen bond. Okay, so let's continue talking about elements, crucial elements. So just 6 elements make the majority of you. So oxygen makes 65% of you, carbon makes about 19% of you, hydrogen makes about 10% of you, nitrogen about 3% of you, phosphorus and sulfur about 2% of you, and if you add all these numbers, it doesn't equal 100. And the reason for that is because you also have other elements as well, such as, for example, iron that is found in red blood cells. Now, if you combine oxygen with hydrogen, that means that oxygen and hydrogen makes about 75% of you. So that means that water makes 75% of you. And this is why it is extremely crucial that you are well hydrated, because you are more likely to die from dehydration than you are to die from hunger. And this is why water is essential to the survival of organisms. And this is why whenever we send uh, rockets to outer space, whenever we're looking for life on other planets, we always try to find water. And it's because water is essential for the survival of organisms.